Electricity powers everything in our world. Our hospitals, schools, factories, transportation systems, communication networks, and much more. Without energy, economic and technological development would not be possible for humankind. To secure our future, it's crucial that our energy infrastructure is operating in an optimal, stable, and sustainable way. Enline is powering that future today. With our revolutionary digital twin technology, we offer an unprecedented cost-effective solution to predict faults and critical events and improve the efficiency and reliability of your energy infrastructure. But what exactly is a digital twin, and how is it making this sensorless revolution possible? Let's take a closer look. A digital twin is a virtual recreation of an object, process, or location designed to reflect its physical counterpart accurately. We built these recreations, gathering available data from the real world. Every component, the way these components interact with each other and with the environment. A digital twin is not just a static representation. With the constant flow of data, changes happening in the real world are reflected in the digital model. As the system ages, gets repaired, and changes over time, the digital twin will evolve along the physical system through its life. This technology allows us to simulate and demonstrate the effects that changes in design, time, or conditions would have on that particular object, without having to subject the real-world object to those changes. So, how do we build a digital twin? To understand this, let's look at a real-world example. One of our clients has asked Enline to build a digital twin for their energy transmission line. Thanks to Enline's sensorless technology, we don't need to add any additional hardware. Our setup process is done 100% remotely over the internet and does not require the deployment of additional sensors. All the information we need is already available through the physical assets and satellite information. This setup process can be done anytime and anywhere on the planet, at unprecedented cost-effectiveness and speed. Let's start gathering all the data to build our digital twin. We need geographic information, the precise location of our clients' towers and other infrastructure, topographical information of the areas surrounding the transmission line, component specifications, tower type, material and dimensions, conductor material and diameter, insulators, all the assets that belong to the transmission line. Now, let's gather information that is constantly evolving. Weather conditions, temperature, wind speed and direction, humidity, precipitation, all the meteorological data from the area, power line information, substation readings, line voltage, static line rating, all the electrical and electromechanical data from the asset. Finally, let's gather the transmission line's historical data, maintenance records that show repairs and replacements of components through time, and outage history that shows past outages and their causes. Now that we have all the data from our client's asset, we can use it to build its digital twin. All of our clients' data is protected with certified cybersecurity solutions. At Enline, we use machine learning, artificial intelligence, physics, and mathematical algorithms to build a detailed replica of the physical asset. This digital model mirrors how our clients' infrastructure will respond to environmental, electrical, and mechanical changes in the real world. It's a specific representation of this particular transmission line, enabling a deep understanding of this system's operations. So, now that we have our digital twin, what can we do with it? This virtual model tells us how the line is behaving in real time, so we can remotely monitor what is happening in the real world without the need of sensors, drones, or engineers doing field work. Even in hazardous situations like forest fires, harsh climate conditions, or dangerous electrical accidents, we know exactly what is happening to the transmission line without putting lives or equipment at risk. But real-time monitoring is just one of the many advantages a digital twin can offer us. We can use the historical weather, environmental, electrical, and mechanical data to identify trends and predict outages, overheating components, vegetation growth, and many more potential issues. Enline can send alerts and information to our client, so operational risks can be addressed before they actually happen. Through our digital twin, we can simulate different weather events and see how they impact the transmission line, then make modifications on our virtual model to improve its resilience. We can test new designs digitally without risking the physical asset, and then apply what works best in the real world. The capacity of the line to transport electrical energy varies throughout the day due to many conditions. Enline's digital model can interpret and adapt instantaneous and historical data to allow line optimization, reducing its losses by up to 30%. We can help our clients create, test, and refine new transmission lines to optimize their performance and resilience in a variety of scenarios. All this can be done digitally at no risk, well before they are built in the real world, optimizing time, money, and resources. These are just a few examples of how Enline's digital twin technology can be an incredibly powerful tool to transform the way you design, monitor, maintain, and optimize your energy assets. Our sensorless, AI-driven virtual models can be used by transmission and distribution system operators, power generation companies, smart cities infrastructure, mining companies, and many more industries, driving efficiency and sustainability across the energy sector. We invite you to experience the transformative impact of digital twin technology and cutting-edge solutions for your energy infrastructure. Join us at enline.energy.